Hello, ladies and gentlemen. Today we're going to talk about calculating atomic mass. So after today, you should be able to calculate atomic mass when provided with percent abundances and atomic mass of isotopes, and compare the relative abundance of isotopes for a particular element. Here are things that you need to remember. Mass number is protons plus neutrons. Isotopes are atoms with different numbers of neutrons. Atomic masses occur with decimal points because they are an average of different isotopes. Atomic mass units are the unit that we use for atomic masses. They are defined as 1/12 the mass of a carbon atom. The way that the atomic mass is measured on the periodic table, so it's the unit that we use, and they're abbreviated AMU. To find the atomic mass, you need to know three things: the number of stable isotopes, the mass of each isotope, and the natural percent abundance of each isotope. Do not forget, all percentages must equal 100%, and all decimal points equal 1. So when we add them all together, we need it to equal 100% or 1, depending on if you're using the percent or the decimal. This is the equation for average atomic mass. Atomic mass of one isotope multiplied by the decimal form of the percent given. Add the atomic mass of the second isotope multiplied by the decimal part of that percent abundance. Here's our first example. Calculate the atomic mass of chlorine if there are two common isotopes. One has a mass of 35.45 AMU with an abundance of 75%. The other one has an atomic mass of 37.29 AMU with a 25% abundance. Okay, so our first atomic mass was 35.45. And that's AMUs. Our first percentage that goes with that was 75%. Next, we have our second isotope is 37.29 AMUs. And our second percent is 25%. First thing we want to do is change these into decimals. So 75% is 0.75. 25% is 0.25. Notice when they add together, it equals 100. So we're doing that right. When we add the decimal places together, it's 1. So we got that. Now to set up our equation, we take the first atomic mass times the first percentage. Add the second atomic mass times our second percentage. Now you enter that into a calculator. When you get that entered into your calculator, you should get 35.91 AMUs. That is our answer. Okay. Ooh. Sorry. Okay. Here here is our second example, and it says, what if you don't have the percentage or the atomic mass? So in this example, we're missing information. So first it says, calculate the atomic mass of one of indium's isotopes. There are two. If the average atomic mass of indium is 114.8200, and one isotope of indium has a mass of 114.9041, and an abundance of 95.795%. So first thing I'm going to write at the top is the atomic mass of indium is 114.82. Then I'm going to write down our information that we were given. Our first atomic mass that we know is 114.9041. And our percentage for that was 95.795. Now, we know nothing over here. How do we find it out? We can't have two variables in chemistry. We only want one. So the way that we do this is our second percentage is going to be 100% minus our first percentage. And that would be our second percentage. Okay? So we have 100 minus 95.795. That will give us our second percent. 100 minus 95.795 equals 4.205%. Now we just have to find out the atomic mass for the second isotope. Converting our percentage into decimal places, okay? Now I'm going to take my first atomic mass times my first percent in a decimal, add, I don't know my second atomic mass, so that's going to be an X, times my second percentage. It's going to equal my average atomic mass up here, so 114.82. All right, here we go. First, now it's an algebra problem. We're solving for X. So first I'm going to take 114.904, multiply it by that decimal, that percent decimal, 0.95795. That's going to give me 110.25 plus 0.04205 X equals 114.82. Subtract 110.25 from both sides, and that gives me 0.04205 X equals 4.57. Now I'm going to take 4.57 and divide it by 0.04205. Sorry guys, we made a math error. This should be 0.0723, which changes all of this down here. So now I take 114.82 minus my 110.0723. So I have 0.04205. And when I subtracted that, I got 4.7477. Now I'm going to divide to cancel this out by 0.04205 on both sides. And I got x equals 112.91 AMU. So my other isotope has a mass of 112.91. Something else you need to know is how to analyze a spectrogram, which is this down here. A mass spectrometer is an instrument used to separate an element's isotopes and to measure their relative abundances. The diagram below is a spectrograph or spectrogram of an element. The upper scale on each spectrograph tells us the mass. So up here's the mass. Down here, the lower scale tells us the relative percent or percent abundance. We're going to use that picture to figure out the average atomic mass. So here's our same picture. We have a mass of B. So this is the element. The element name is B. Here we have the mass on top, and below here we have the percent abundance. Based on the experimentally obtained values of mass and percent abundance, calculate the average atomic mass in AMUs of element B. So here we have our first mass is 26. We're going to multiply it by our first relative percent. We're going to move that into a decimal, so it's going to be 0.112. Then I'm going to add my second one. 25 multiplied by our percent abundance, 101. 0.101. Our next one, we have 24 with an abundance of 0.787. I'm going to add all that together, put it in my calculator. 26 times 0.112 plus 25 times 0.101 plus 24 times 0.787. When I add all that together, I get 24.325 AMUs. Okay. Now in letter B, it asks us, what is the name of element B? If you look on a periodic table and try to find this atomic mass, you're looking for the one closest to it. I'll give you a second to look it up. Looked it up. You should have gotten magnesium as the name. Identify the number of protons and the mass number of each isotope of element B. So we have Mg. We know there are 3 because there are 3 different bars here. Magnesium always has the same atomic number, same number of protons. That's what makes it magnesium, of 12. When we look up here, it tells us each of the mass numbers. So I have one that's 26, one that's 25, and finally one that's 24. For homework, you guys have 6 problems. If you have any questions, feel free to ask during normal school hours.